All right, let's go ahead and do it. Example 6. Let's go ahead and factor. We have the numerator factoring into x and minus 2 plus 1. And then over x minus 1. Okay. Negative 2. Okay, just double checking. Let's do the whole first. There's nothing to cancel out. No factors, common factors in the numerator and denominator to cancel, so no whole. And then I like to do my vertical asymptote next. And my vertical asymptote are the undefined points where your denominator equals 0. So vertical asymptote, we want to figure out what makes the denominator undefined or equal to 0. So we're going to take x minus 1, set it equal to 0, and then we get x is equal to 1. So x is equal to 1. So let's put that dashed line in there and block off our graph. And then the horizontal asymptote would be next, and if the degree of your numerator is less than the denominator, it's the x-axis. If the degree of the numerator is equal to the denominator, then it's the coefficients. And if the degree of the numerator is greater than, there is no horizontal asymptote. And if it's exactly 1 greater, there's a slant. So we do have a slant. So we're going to do division. We're going to do long division. We'll take our denominator and divide it into the numerator. And then we're going to multiply by x to make x squared. Just don't forget to distribute to the full x minus 1. So then you get x squared minus x, and then we subtract. That's going to cancel out. X squared minus x is 0. This is going to become positive, and you get a 0. Negative x plus x is 0. We'll bring down the negative 2. And then you would be multiplying by 0 to make your 0x. And you would get 0x plus 0. And then your remainder we would subtract. Your remainder is negative 2, but you can ignore the remainder. And we get y equal x. And you don't really need the plus 0, but that's your intercept. So your b is 0 and your slope is 1 over 1. And then I can just use my little dots here that I'm using to slope it. Use those as my dashed line. Okay, so then our y-intercept is when x is equal to 0, so you get negative 2 over negative 1, which is 2. So 0, 2, 0, 2, and 0 up 2. There's your y-intercept, and then your x-intercepts are your zeros, and that is when your numerator is equal to 0, because when you find your x-intercept, you let y equal to 0, and what's going to make your y equal 0 is to have 0 over whatever on the bottom, and that'll 0 over whatever would be 0. So we need to figure out what makes the numerator equal to 0, and the factored form is x minus 2 times x plus 1, set that equal to 0. I'm going to cheat here on mental math. X minus 2 equals 0, x would equal 2, and x minus 1 equals 0, x would equal negative 1. So at 2 and negative 1, you got some intercepts. So negative 1, there's an intercept, and over 1, 2. And then you can get extra points in here. But I'm just going to go ahead. That's pretty bad on this side. I'm going to go ahead and just graph it and hug my asymptotes. And then I'm pretty sure my graph's going to look, I don't know, something like that. So if you want to check some extra points, you can get some extra points I'm going to cheat and plug it into my graphing calculator because I don't feel like doing them by hand. We can sneak a peek at the graph and see how if we did good. And it looks like we did good. You could zoom in if you want or change the window to look a little closer. And then we're just going to look at the table. So when x is -2, then our y is negative like 1 1/3. And that looks like okay-ish. The way I graphed it, when x is, let's do on the other side over here, when x is 2, +2, oh, I already have that point. Your y is 0 when x is 3. When x is 3, 1, 2, 3, your y is 2. So it would be like right up here where my arrow is pointing. So that's close enough. So you guys can just, or you can, sorry, just get some extra points and plot them if you want to, but this is a good enough sketch for me.